For this next question, we're given this equation here, and we're asked to find a few things. The equation of the tangent, the equation of the normal, the angle of inclination at this point. As I explained in the previous question, 3a, you might like to go and look at that. The things that we need when we're trying to find the equation of the tangent and the normal is the gradient. We find the gradient by using the derivative, because the derivative is called the gradient function. I've already started this question. I've used the quotient rule. You might like to pause this video, go through, see if you can get the same answer. This is my gradient function. With this, what I need to find is mt. This is the gradient of the tangent, and I want to find that at the point where x equals 4. That was the x coordinate in my point L. To do that, what I'm really finding is the derivative at the point where x equals 4, and mathematically we write this as the derivative evaluated at the point 4. So I'm just going to turn the page. Y dash of 4 will be equal to, now it was x squared, so that's 4 squared. 2x is 2 times 4 plus 4, all divided by x minus 1, which is 4 minus 1, all squared. Just need to evaluate this now. 16 minus 8 plus 4, all over 3 squared, which is 12 ninths, which I'll write as 4/3. That is the gradient of the tangent, that is 4/3. Now using my point gradient formula, and the fact that my point L was the point 4, 4, I plug in those values of y1, x1 and m into this formula. Y minus 4, 4/3, x minus 4. And then just rearrange. This here is the equation of the tangent. We also want to find the gradient of the equation of the normal. And to do that, we need to know that the gradient of the normal is the negative reciprocal of the tangent. So therefore we've got, if this was 4/3, then the normal is minus 3/4. The point L still hasn't changed, it's still 4, 4. We still use the point gradient formula. Y minus y1, y minus 4, and this here is the equation of the normal. We also want to find the angle of inclination. To do that, we need to remember that the gradient of the tangent was 4/3. We use the fact that the tan of an angle will equal the gradient of the tangent. So the tan of my angle is equal to 4/3, therefore the angle. So I just get out my calculator. What I want is the tan, inverse tan of 4/3 again, this is to give me the exact value because I've got it set to standard. If I press this button here and turn it to a decimal, I want this in degrees, minutes, seconds, so I just go interactive, transform to DMS. If I leave it blank and just press go, it uses the answer that I had before, which is exactly what I wanted to do. And I can see here that it's 53 degrees and 8 minutes when I round that up. 53 degrees, 8 minutes. Oops, it should be 8 minutes. That kind of makes sense, because if the gradient was 1, my angle would be 45 degrees. My gradient is a little more than 1, and my degrees is a little more than 45.